Good morning, good afternoon, whichever it is for you. You just can't get rid of me, can you? Okay, let's do a little bit of note-taking together. We're going to use the same quadratic formula we did yesterday. What's different today is that our expression b squared minus 4ac under our radical sign, we have to know what are we going to do when it is not a perfect square. So when it's not a perfect square, you will need to round your answer. And we'll go through that together. So our quadratic formula, let's write it down. We have x equals the opposite of b plus or minus our square root of our expression b squared minus 4ac. And we're going to, just like we did yesterday, I suggested changing this to add the opposite. I find students are more successful that way. And then we have a fraction bar underneath that long numerator. And downstairs we have our 2 times a, 2a. Okay, so let's take a look at our first one we have here. It is in standard form, set equal to 0. So we can go right to identifying our a, b, and c. A equals 2, b equals negative 8, c equals 1. And now we will substitute into our quadratic formula, which you still have in front of you on your notes. So x equals the opposite of, we're putting a negative 8 in for b. We have a plus or minus, our radical sign, and underneath there we're going to have in parentheses because it's negative, negative 8 squared. We have plus our negative 4, and that gets multiplied times our a value, which is 2, and our c value, which is 1. And then we have our fraction bar, and downstairs we have our 2 times our a value of 2. So again, just like yesterday, we're also going to just not take do too many things in one step here. So we will have x equals, the opposite of our negative 8 is positive 8, plus or minus. I'm not going to get rid of our radical sign yet. We have negative 8 squared, which is 64. And then we have our negative 4 times our 2 times our 1. That is negative 8. And downstairs we have 2 times 2, or 4. Okay, the only thing we're really going to need to do in this next step is simplify what's underneath the radical sign. So we're going to have 8 plus or minus radical 56 all over 4. 56, not a perfect square. If we were going to do that on our calculator right now, just taking just the square root of 56, we would find that we would end up with a number that does not repeat, does not terminate, so we have an irrational number actually, so that's what's going to lead us to having to round our answers today. So we have, I'm going to show you how to get the closest answer you can though. We're going to break this into our 2 problems that we do, just like yesterday. But we're not going to evaluate radical 56 right now. We're going to say we have x equals 8 plus that radical 56. But because we want that whole numerator to be divided by 4, we're going to have to stick it in parentheses. Now what will happen is your calculator might also start a set of parentheses when you want to take the square root of something, so you have the square root of 56. If it starts a parenthesis there, you're going to need to close that parenthesis and then make your second closing parenthesis. So you may altogether have the 2 opening and the 2 closing. And then we're going to do, with our division key, divided by 4. When we do this, we end up with a number that we're going to have to round. I want you to look to the, just take it, look 3 places behind the decimal, and look to see what is in that thousands place, deciding if that should round it up or if it should stay at the number of hundredths that are already there. This one, we should actually end up with 3 87/100. There's one of our solutions. Our other solution will come from, again, we're going to do, but this time we're going to subtract radical 56. But remember, that needs to be in parentheses. And so, again, if your calculator wants parentheses around what you're taking the square root of, make sure that you close that before you close the numerator's one, and then you're going to divide by 4. And you have the same thought process. What is in the thousands place? Is it big enough to round up, or do I leave it as it is? Last time, the 87/100 was followed by something that was not big enough, so that's why we left it 87/100. This time, I believe you should have a big enough number to round that 12/100 to 13/100. So we have 0 and 13/100 as our other solution. Now what you have to do is you have to become friends with your calculator to make sure you understand how to input this correctly so that you will get good answers. So if you're having any trouble with that, make sure that you are playing around enough with your calculator to figure it out, or asking a neighbor who maybe has a calculator like you and they've gotten theirs to work, they can show you. But it's your responsibility to make sure that you figure out how to use your own calculator, because we like to use them, right? Okay, we're going to move on to the one on the back. I hope you're ready. For this one, again, it is already set equal to 0. The polynomial part is in standard form, so we can go to work writing down what our a is, which is 3, our b, which is 0. There are no x terms, and c equals -15. We still can use the quadratic formula when b or c are 0. So we have x equals the opposite of our b value, which is 0, plus or minus our radical sign. We're going to be squaring b, which is 0, plus a -4 times our a value, which is 3. Keep having to extend my radical sign. Times our c value, which is -15. And that is all over 2 times our a value of 3. So after we have our substitution step completed, now we're going to say, well, the opposite of 0 is 0, plus or minus. 0 squared is 0, plus a negative, it's not going to be negative because we have a negative times a negative here. So we're actually going to have a negative times a negative makes a positive. 4 times 15, that's 60. 60 times 3, that's 180. And downstairs, 2 times 3 is 6. Okay. That 0 that's in the beginning is useless, so we're actually just going to ditch it. This 0 plus 180, that's pretty useless, so we're just going to ditch it. So we really have here x equals a positive negative radical 180 divided by 6. Well, in reality, we should be able to just do this on our calculator one time, and we would have the positive of it and the negative of it. So what we're going to do is we're going to remember we have a positive, negative. So we have x equals positive, negative, and we're going to put in our calculators. We're going to say, what is the square root of 180? And again, your calculator might do this. It might set that parenthesis Now notice we didn't put a parenthesis in front of our square root of 180 because there wasn't anything else in the numerator to have to deal with. So we just really have the square root of 180, and we're not going to worry about this part right here right now. We're just going to bring that down, okay? And so we have the square root of 180 divided by 6. And we're going to approximate, look at the thousands place, decide what we should do with the hundredths place, and we should determine that we have a positive and a negative 2 and 24 hundredths as our solution. So rounded to the nearest hundredth, we have both a positive 2 and 24 hundredths as a solution and a negative 2 and 24 hundredths as a solution. This is what we're doing today. All of your problems, 9 of them, should be of this type where you're going to have to do you're going to have to be rounding as we were doing. And then the 10th problem that you have in the homework, they're asking you to solve it by all of the ways that you know how now. And I have some post-it note graphs that you have to graph it. So you can grab one of those. You don't have to draw your own coordinate plane on your paper. You can just grab one of those post-it notes and then you can stick that to your assignment and do the graphing on that. So happy homework!